So my name is Evgeny Kabanov. I'm the CEO and founder of Zero Turnaround, a company you may or may not have heard about. And today I'm going to speak about class loaders, or how we tend to gently call them in Zero Turnaround class holders. The talk, this talk is usually very, very interactive. This talk is also usually in a smaller audience. Oh, well, I have a working mic now. It's on the wire. Yeah, that's bad. I generally like walking, but yeah, I guess I'm just going to stand in front of it. So this talk is typically very interactive, which means that I actually ask questions from the audience and expect the audience to answer me. Unfortunately, well, this is a bit large audience for this. So how about the first, 3 to 5 rows are on the spot? So the fate has decided that you guys are going to be. Are going to be, and actually the first row, of course, I'm going to come personally ask you and stare at you until you answer. So I will expect you guys to work along with me, otherwise it's kind of boring. The rows behind you can also work, you just have to scream really loudly, otherwise I won't hear you, but otherwise you're totally welcome to scream, your lungs off. And also classically, I let you to interrupt me with questions. Again, here it's going to be tough, so let's say this way, you can interrupt me with questions, but I can dismiss them if I feel that it's just too much. So, my background is I'm a software developer. I have a computer science degree. I have a lot of stuff. I've been working on virtual machines, programming languages, all that kind of stuff for many years. Have published, have done all kind of stuff. So, I have some background which says that I'm not a complete idiot, and that actually what I say is not complete bullshit. But still, obviously, everything has to be verified. No, I'm just joking. It's all complete truth. If you'd like to comment something, a good place to comment is also on Twitter. So whip out your iPhones and Androids and Windows mobile phones and comment at ekabanov or like some, hash class loader or something. So, whip it up, guys. Don't make it boring. I don't like it boring. So again, the background of the company, we're mainly known for a product called Arable, which is basically prevents redeploys and restarts and builds in development, so allows you just to edit code in your IDE and immediately see feedback in the browser. We are pretty good at that. We have a lot of customers, happy customers, and I hope some of you will join those ranks. But the talk is not about that, though. If you do want to try it, then you can get it for free on myjarable.com. But the talk is actually about what we did when we were making Arable, and we had to do a lot of very, very hairy, very weird things. We had to hook into the class loading on JVM levels in many different JVMs. We had to plug into the class loading in many different app servers. The latest test matrix that I've seen tests 22 versions of JVMs and 55 versions of different application servers. So that's a lot, which means that we know more about class loaders than anybody ever would want to know. We solved hundreds, literally hundreds, even maybe today thousands of issues connected with class loaders. And we got very depressed, but then we decided that, the depression, all this effort has to get somewhere, so we made this talk. And actually, interestingly enough, next month we're also releasing an ebook, which is basically the content of this talk and then some. So next month, if you search for Zero Turn and then class loaders, you will get the very nice, very, very nice materials. I think that the release is something like 19th October. Okay, this is the next month, not next month, this is actually already this month. I'm a bit confused here. So obviously, I stand on the shoulders of giants, and in this case, 2 giants, or the 3 giants is, first of all, Vijay Saraswat, who wrote the paper that Java is not type safe, which was a seminal paper which changed a lot of things in Java, which I very much recommend you to read if you have time and wish. And also Sheng Liang and Gilad Bracha, the dynamic class sorting in the Java virtual machine. So these guys came up actually with the whole idea how to use class orders for dynamic class reloading. This is a very interesting paper. It talks a lot about why class orders are actually as hard as they really are. So today we're gonna cover the basics pretty quickly. We're gonna talk about problems and solutions, and this is the bulk of the talk. It's about, I'll show you a particular problem and ask you how would you solve it, and then I would try to suck out the solution out of thin air, if you can't really tell me. So then we will talk about why class orders is so troublesome, why do they leak, why it's very typical for applications to go without memory errors in production. After a lot of redeployment. And then we will not probably talk about OSGi, Spring DM, JBoss, and others because there's never time. And anyway, they're less interesting than the rest of the stuff because the rest of the stuff is more practical. So, and then we're going to discuss just kind of a bit of future and a bit of conclusions. All right, so just let's start with basics. Here's the class order. He's a little bit shy, but he's actually in the Java Lang package, and not a lot of people seen him. So, but really, first of all, class order, it's an object, so it's an abstract class, and then the actual class orders will extend that class. There'll be actual objects in memory which will do things. By far, the main method of the class order is load class, which gets the name of the class. What's called the fully qualified name, so dot separated, a.b.b, c.class, my class. So, and returns an object of class. There's going to be a lot of that thing going on, the whole class thing. So, and this is basically the representation of the class as loaded by the JVM, from which you can now create objects, from which you can now manipulate, so it's already exists for the JVM. Another important method is define class. So this is actually internally, the method used to materialize the class for the JVM. So the byte array, it's actually what is called the class bytecode. So it's the actual, it's loaded from disk or loaded over the network or whatever. But in the end you get a byte array, which is a representation of the actual class. And then the define class method loads it into the JVM, loads it into memory, materializes it, initializes it, blah, blah, blah. Get resource and get resources are very important methods. They're the other part of the class order contract, and this is kind of the class path contract that class order can take a name and return a URL or return a resource. It actually also can return directly an input stream. So, and one of the important part is that that get resource, if you give it a class resource, right? So, this a/b/c/myClass.class, there's actually an unwritten contract, but nevertheless a contract that it will return it as a URL, it will return it as a resource. So, so get resource and get resources there. Very, very important sometimes, and you can use them to load resources and for other more interesting things as well. And finally, every class loader has a get parent class, which means the class orders form a hierarchy, right? So remember, this is an object hierarchy, not a class hierarchy. So, my particular object has a parent, and then that one has a parent, and then at some point there's a system class order on that one. And then the bootstrap class order is actually something weird, so it's not real. It doesn't have, it's a null very often, on some versions of JVM at least. Okay, so that's an interesting thing to know about class orders, and which explains a lot of them. Originally, class orders were motivated by applets. Remember, in 1995, applets were all the rage. They were going to be what Java was all about. So, and one of the issues that we had in 1995 is we had those things called modems. Some of you might not actually have seen them, but they were real. They had the whopping speeds of, maximum 56 kilobits a second. It took 24 hours to download one album of music from Napster, and I didn't say that. And so one of the motivation for class orders was that class orders allowed you to load one class at a time over the network. which was supposedly faster. It still seemed like a lifetime, but it supposedly was faster. So really, like largely in the at least Java 1.0 and Java 1.1, class orders were largely motivated by applets. So this actually explains a lot about them. And also by the loading resources over the network, right? So get resource, and since get resource and like load class, they're all completely abstract methods, then you can actually, you can actually load them over the network. Nowhere is said that they're backed by a file system or something like that. So class loading, so this was the first part, all you need to know about class. This is the second part. So class loaders are actually work in a way that everything in Java is super lazy. Everything is done at the last possible minute. And typically a class will be loaded when it's referenced somehow. And it's referenced either by a constructor, by a static field, by a static method, or that's it, pretty much. So constructor, static field, or static method. There are also some reflection, some ways to load it through reflection. So, and when it's referenced, then what happens is that it's not really that particular call, but it's completely semantically equivalent to that particular call. And so what do we do? So first of all, we do a.class. So that's just a way to get the class object of A. And then we do .getClassOrder. So every object in Java is associated with its class. Every class in Java is associated with the class order that was used to load it, right? So this is our true kind of context class order, which is very confusing because there's another context class order, but basically that's the class order that was loaded as, and then we use that class order to load class B, right? So this is how it always happens. And okay, that's all about the basics. Any questions? Good. So let's get to the interesting stuff faster. So class loaders have a parent class loader, but really, why is that important is because typically the parent will be consulted first, right? So this was originally motivated basically because you didn't want to load the same class several times. But in Java EE, it's actually reversed. Right, so if we watch the next slide, so this is like a typical web container or application container, more likely. So it has a class order for container. It actually has a ton of class orders for container. It has a class order for each EAR, and it has a class order for each war. And again, this is hugely simplified because if you just start up JBoss, you're going to get 90 class orders without anything deployed yet. Right, so. But in a very simplified worldview, which is what we are interested in, this is how it looks. And the wars are very special because whereas every other class order, when it gets this load class method call, it will first ask the parent class order, can you load it? Right. So for example, in case the parent class order has a shared library, then you always want to load it from there so that you won't have duplication. Then the war class orders, they're exactly reversed. Like they will first of all try to load the class themselves and then delegate to the parent. Why was it made like that? The reason is that at that point there was this problem that containers would ship with a bunch of libraries, and then the versions would be very old, and then people wanted to override them. Like for example, classic was like log4j and so on. So the designers of the Java EE container, they wanted to guarantee that the web application actually runs with the versions of libraries that it is shipped with and not the ones that it loads from the container. And so that they did this, search the war first. That probably caused more problems with class orders than anything else ever. So that was kind of a shaky decision, especially considering that later down the line, every container started, if they shipped some standard library, they would actually rename the package because the conflicts was still too problematic in reality. Okay, so that's all. That's no more basics. Now we go to the problems and solutions. Still no questions? Well, maybe I'm just, yes, sir? Oh, you have to scream, I'm sorry.
When you speak about class loading in Java EE, you say that we begin to the top. Is it standard or is it a pure implementation?
Okay, so the question was how does the delegation, I think the question was how does the delegation work in Java EE? And so it's from bottom up, so bottom class orders delegate to the top ones. So war delegates to ER, ER delegates to container, container delegates to system and bootstrap. The only difference is that war will first check itself and then delegate, whereas ER will first delegate and then check itself. Right, so that's the only difference. Right, so let's go to problems and solutions. And now we go away from slides, almost never to return. And now I'm especially, my giant laptop doesn't let me speak very well. So, the clips. Okay. Right. So, what happened? Hello? So that works, but this doesn't. I was trying to disable the scroll. I think it's very annoying. Okay. Yeah, I don't know what happened here, but it's fine now. All right. Sorry about that. So this is our first program. It's very, very complex. So it's a servlet, which is called test1. And all it does is out.print util1 say hello. Say hello, returns hello. Very complex code. You probably haven't seen that complex code in a while. Oh, sorry. But when we actually go, so it runs in Tomcat and all that, but when we actually go here, then something bad happens, get an exception. So now imagine this is, this is your production. So what do you do? How do we solve that? What happened? Everything worked in the IDE. So this is one of the simpler problems, but I still like to solve it. So what should I do now? I am at loss.
Util1 did load.
Sorry?
Util1 did not load.
Okay, so util1 did not load. Why? Unpack the war. Well, so I don't actually know where my war is. Well, okay, so you should find the war. But how do I find the war? So here's an interesting thing. Modern containers are really, really annoying. And when I mean annoying, I say complex. Well, probably should have said that vice versa. But reality is that modern containers will cache a lot of things. They will unzip things in weird places. They will put things with weird places. And you actually can never be sure where is that from. So if you get ClassNoDefError found, typically, although it's useful to check the war file if it's actually there, it actually might be there, and it's still a problem. So there's tricks which you can actually do for that. And one of the interesting tricks is that you can actually, in many containers, not in all, but in many containers, you can get the, you can get the container or class order to confess where is it loading things from. And the way you do that is that, so I take the test1, I get its class order, and then I cast it to URL class order. So that doesn't always work. Sometimes it doesn't work, because not all class orders descend from URL class order, but in a lot of cases it does. And I will also talk a bit about what happens if it doesn't work. Damn it. So URL class order, there we go. URL class order actually has a method called getURLs, which returns the class path, right? So all the entries in the class path. And if we now refresh, then by the way, we'll find out that our class path is really strange. It's, as I said, like modern containers are very annoying. Modern IDEs are even more annoying. So my war is actually somewhere, heaven knows where. But the important part is that I can now go here. We're in the jar file where this class was supposed to be. So I can go there. And I can actually update it. And I can find out that the class is actually missing. So why am I going so? Why am I, it's such a simple thing. Why am I doing so complicated example? Why am I solving it in such a complicated way? Well, one of the biggest problems with class loaders, and this is less visible here, but it's going to be more and more visible with every next example, is that, damn it. I'm recently using Keynote a lot. So one of the problems with class loaders is that class loaders all class loading happens at runtime. So all the things you built, all the things you compiled, everything you did in the IDE, it's always irrelevant. Class loaders all happen at runtime, and which means that the assumptions that we usually make, they're kind of static in our head. They're usually incorrect. So the most important things with class loaders is you have to always validate your assumptions. And for example, so for the particular class not found problem, it's by far the simplest one you can get with class loading. It usually has one of the two variants, either class not found exception or class not found error. Damn it, error, not exception. So the first one happens when it's expected, the second happens when basically class loading fails. Like really if you do a new B and B cannot be loaded, then that's the class not found error happens. And what you can do, well, you can do the D class lookup, you can do the searchers, but in reality, this doesn't actually tell you where the container loads classes from. Unfortunately, there's not amazingly great ways to find that out, because basically the class wasn't loaded, so there's no information about where it wasn't loaded from. It's a negative, but it's usually worthwhile to either try to get the URL, get URLs, URL class order get URLs method, or if that doesn't work, then just try container-specific logs. For example, in JBoss and in some others, you can actually connect through a JConsole, and for most class orders, you can basically just, for a particular class order, you can ask what's its class path through the like this JMix interface. Okay, so that was the easy one. Let's go a little bit more hard. The code is way more complex now. Let's do test 2. So, it's very, very complex code now. Much more complex than in the previous example. And let's go to the actual thing. Try it. Ooh. So no such method error, but it clearly works. What's happening? Why is there no such method error?
The class is different.
The class is different. Okay, why? Different version. Why? It was cached. Quite possible. How do I control that? How do I find out? Okay, so it's a relatively common problem, and this happens, yes, when the wrong version of the class has been deployed for some reason instead of the correct one. This usually happens either during version mismatch, like you deploy an application with the wrong version of the library. It happens in unfortunately, many other cases as well. Caching is a cause, other things that can be a cause. And no such method error is actually by far the easiest. I'll show you a few others later, which are much harder. And what you have to make sure is actually you have to understand where has been the class loaded from. To solve the problem, to truly solve the problem, don't just start hacking away like I'm going to just put the class into a clean build. Try to understand what actually happened, where it was cached, why it was cached, why the wrong version. And to do that, we need to understand exactly where the version was loaded from. So luckily, the JVM provides a wonderful tool for that, which is called -verbros column class, I think. I'll check later, which actually shows you where every class is loaded from. So that's the easy one. But if you don't like restarting the JVM, like I don't, and if you can just debug a little bit, then another way to find out where the class was loaded from is to use, remember I was talking about that for every loaded class, you can also use the method getResource to get the URL. So we can just use that. We can call it, so let me just copy it first, and then I'll explain what happens. So now what we're doing, we're getting test2 class, we're getting the class loader that loaded us, we're saying give me the resource, and then we're saying this is a util2 class get name. We replace the dots with slashes, right? So it's a.b.c, now it's a/b/c, and we have .class. So we get the actual file name of the class, resource name of the class, and when we do that, then we find out where it's loaded from. All right, so it's loaded from here. And then, since we already did that, and it's in the same place actually, so it's util2.class. I'm just going to get it bigger again. So it's util2.class, and it's again in some totally weird place, which I never would know where to look at, right? So tmp0/whatever. And let's just check what happened. So Java actually ships the very nice tool called JavaP. JavaP allows you to disassemble the class, but also very easily to dump the class structure. By default, it actually will dump the structure. So if I just do this, I can indeed see that the util2 does not have the method, right? So I verified all my assumptions. Now I know that this is where it's loaded from and that it really doesn't have the method, so everything is correct. Why would I want to go to such lengths verifying my assumptions? Well, for starters, as I said, no such method and no such field found error is by far the simplest of the ones you can get. So you can get an abstract method error if, for example, if the method you're calling is an interface and the interface is there, but the class doesn't actually implement it, or the class implements it but doesn't. The class implements it but doesn't actually have the method for some reason. Or if the method used to be abstract and now it's not abstract. So it's like the abstract method error is very annoying. Class cast exception, if for example you're calling an interface and the target class actually does not implement that interface, what you'll get is class cast exception. Actually, you can get even worse. Yeah, I'm actually thinking if you can also get even by far worse things from there. But a class cast exception is fairly reasonable, or unreasonable actually. That's what happens. I'm thinking actually you'll get even a linkage error from there. So the point is that an illegal access error, for example, if a method used to be protected or a field used to be protected or private and now it's public, right? And you have the old version, you get an illegal access error. So this wrong class found, it's a very large class of problems, and usually they look very, very weird, right? So the one that I shown is by far the simplest. So what is important for a verbose class? If you can do that, class where to get resource, and always verify that yes, actually, verify your assumptions by doing the JavaP or like looking at the class with some other bytecode editor, because honestly, the first thing you always want to do with clusters is verify your assumptions, because it's so easy to assume something wrong and then just spend a lot of time battling, this like Don Quixote, the watermills, or what were they? Windmills. Watermills. Fighting watermills is an interesting image. Okay, so, yes, sir?
Does the get class loader.get resource work for classes loaded from the bootstrap?
The question is, does get class loader get resource work from classes loaded from the bootstrap? It's a very good question. I'm actually not sure outright. I would say I would posit that yes, but I'm not sure. Was there any other questions, sir? Okay, so the question is class not found exception and class not found error. Again, error, damn it. There's no substantial difference except that class not found exception is thrown mainly by reflection methods, where you explicitly load classes or something like that. A class not found error is thrown from like random place in your Java code, where you're trying to access class B and it's just not there. Right, so there's no way to throw an exception from there because you don't expect a checked exception, so an error is thrown, and that's the ClassNoDefError error. So there's no substantial difference. They report exactly the same thing, but just their checked exception is thrown there, mostly from reflection methods, and the error is shown when actually you're not doing anything with exceptions. Okay, so the next problem, even more interesting one. Okay, no problems this time. Ooh, so now I have a factory. So in the future, obviously, in the future, I plan to add all kind of XML and all kind of interesting features. But at the moment, the factory is fairly simple. So I have a factory class which returns instance typed and then say hello. So if you actually look at util3 say hello, then it's again the same. So nothing changed here. But if you looked at the factory 3. Then it's basically returns a new util3, right? It's a very, very simple method actually. Everything seems to be very easy, and we have to cast util3 because it returns an object. but otherwise everything is fine. Okay, so let's see what happens if we do that. Woo! Class cast exception. Util3 cannot be cast to util3. Who has seen that in production? All right, you two guys are the closest. Tell me what does it mean. Different versions. One. Okay, we have one. Different versions, different class loaders. Any more? Make mistakes, guys. Ooh, he knows his thing. So when you see that, you're guaranteed that there's two different class loaders in play. And here I'll make a very interesting historical note. Why does this even happen? So in 1995 again, I think, or 1996, when Java 1.1 came out, then basically every class was always uniquely identified by its name. Unfortunately, what this, and God, I can never remember his name. What's the guy of the first paper identified? Was that unfortunately this means that applet can create a Java-lang string, and because it's only identified as a Java-lang string, then it can inject it into the sandbox and actually subvert the virtual machine, right? And because Java was all about security, we couldn't allow that. So what happened that actually Gilbert Bracha and Joshua Long, I think, wrote their paper, and what they said, what basically happened in Java 1.2 is that the mechanism of class loading was changed. And what happened is that now a class was uniquely identified by its name plus its class loader, the class loader that loaded it. So that means now that even if you manage to define Java-lang string, which is also impossible for different reasons now, but if you manage to do that, it will not be compatible with the actual Java-lang string because it was loaded in a different class loader. And this is what we see, this is the result of that. So util3 and util3, they have the same class names, but they have two different class loaders. So now the question is, how do we find out what the class loaders are and what is the problem? So the first solution is actually the same as in the previous problem, that if we can add -purpose column class, we'll actually see where what class loaders loaded both of those classes, and we'll also see where they were loaded from. But again, because I'm lazy, I'm going to use the same solution as previously, and again validate my assumptions. So just copy those two. So let's see what I'm doing here. So look, first I'm taking the test3 class loader get resource, and then I'm taking factory3 get class loader get resource. Why? Because I'm loading here through util. Sorry, I'm loading here basically one util3 directly in that context, and the other one in the factory3 context, right? So both of them refer to util3. So let's see what happens. And by the way, it's Arable doing the reloading. So that's why I can just zoom. Okay, so it turned out that some complete bastard had put a jar into Apache Tomcat. So if I find him, I kill him. Anyway, and actually, so you would think that this is like a very constructed problem, but actually, it's surprisingly not so rare. Sorry, actually, I forgot to finish first thought. So it's not so rare. Why? Because the TAM containers ship libraries, which means that you almost always already have the situation whether you have same classes in different class loaders. The only thing you're missing is that they have to somehow be met in the same place. Let me see what I have. Sorry. Yeah, I have the slides later, which I was interested in. But here's the interesting thing. This would never happen if the war class loader wouldn't be reversed like that, right? If it wouldn't have reverse delegation. Because if it wouldn't have reverse delegation, then it would actually load the same classes in both places. It would load the one in the application container, right? So remember I told you that this fact that the web class loaders have reverse delegation is the root of all evil? Well, there you go, a live example. And so if you have like Log4j or Hibernate or something like that bundled with container, you're not unlikely to get to this error. Though, actually, let's see the next problem. And that one gets even a little bit interesting. So test 4 actually uses all the same. So we again have, sorry?
So actually, be able to solve that just rebuild from the but what if we cannot do it? So, for example, I have a different version of the same thing.
Okay, so the question is like, okay, here we could remove it, solve it very easily by removing the jar file from the container, but you know, if it's bundled with the container, we can't really remove it, right? So how do we solve it then? Well, either we remove it from the web application, or we just make damn sure that they never are used in the same context, right? So just like you can actually make sure that it's just very painful. Yes. Well, we use Maven, but it's irrelevant because this happens at runtime. So. No, sorry. That like the question was, can we solve it in Maven or like in IDE? But the reality is that this is a runtime problem, so it all depends what has the container cached, what was deployed by other people besides you in previous views. Like it's fairly complex. Okay, you can ask more questions later offline. So the next is actually, this is the same setup. We still have the two class headers, right? Because I'm using the same factory 3, I'm using the same test 4, so we have all the same situation. The only difference here is that instead of using the instance of type, which returns an object, I'm using an instance which returns util3. And let's see what happens then. And then we get this wonderful thing, which I'm much more likely to encounter than the class cast exception, which is LinkageError, loader constraint violation. And then like a bunch of information. So this is actually something you're much more likely to encounter because the class cast exception happens when you actually cast something, right? So if you actually have a cast, but this is what happens if you don't have a cast. Right, you have two class orders and you're trying, and this loader constraints is a mechanism how to track that you're using multiple class orders in the JVM. And this is exactly what Gilad Braca actually was writing in his paper about. And it's a fairly complex mechanism, but what it does is basically if you try to use two different class orders with the same class in the same context, right? So you basically, let's see what, I'm just going to refactor the code a little bit to make it more understandable. Test 4. So if I just introduce a variable here, so we actually have two different contexts here. Like one util3 in one class order is the one that this returns, and the other util3 in this class order is this method invocation. Because this method invocation happens in current context, whereas the loading of the class happens in the context of factory 3, right? So. And the reality is that it's very hard to understand. It's really, really hard to understand from code. It's and the only way to understand it again is to do the same way we did previously, right? So it's actually exactly the same, but I'll just copy it just for funsies. So I'm just going to replace this with test 4 now, right? And hello, what happened? Did I do something bad? Yes, I did. Okay, so in reality I even was lying to you because there's already before two contexts. But it doesn't change anything. The point is that we still have two class orders and we have two contexts in the same statically compiled file, right? And already if I even just, I think even actually if I do this, then I get an error, right? So it's kind of weird, but it's, there always are two contexts, one which returns, the one in which you're calling, and Java will throw such an error. So what do you do when you get such an error? Well, you know that you have two class orders, you verify your assumptions, you find out where they're loaded from, and you solve them the same way. But actually, just very quickly, I'm also going to show you test 5, which is the last of this. part, and here we do almost the same, except the method that we're calling is package. It's a package method, right? So it doesn't have public or private in front of it. But it's not a problem because factory 3 and test 5, they're all in the default package, so it's the same package, right? Unfortunately, if you actually try to access it, then we get illegal access error. Who can tell me why is that? Sorry? So the hypothesis is that the security check is done before the class is actually loaded. Fortunately, it's incorrect, but it's a good hypothesis. Okay, so so it turned out that when the change was made and the classes became fully identified by their name and their class loader, it turned out that the same had to be done to packages. So actually, the full identification of a package, and this is really weird, is the package name and the class loader. And so default package in default packages for classes loaded in 2 different class loaders is actually not the same package. So if you're trying to access a package protected method again across class loaders, you get an illegal access error. Very interesting thing. All right. So the more than one class found is one of the most common problems in production, or at least one of the most common problems which are really, really hard to solve. So, and now you know how to solve them. So what you do is verbose class order get resource, and you find out where everything is, you verify all the assumptions, and then you fix it, right? By basically making sure that classes are not used in the same context, or even better, making sure that there isn't 2 sets of classes to begin with. So this is actually the same problems we're looking, just to refresh. This is how it actually looks. So we have 2 class orders. We have the web class order and we have the shared class order. We have util 3 present in both of them, and then we have just 3 in one and factory 3 in the other. And this is what actually happened. Okay, are there any more questions about this? All right, I didn't hear that, so I'll pretend that it never happened. Okay, I'm just going to take a look at... All right, I'm moving fairly slowly. I should move faster. So the next problem is almost entirely... Okay, actually, there's one slide, and then it's almost entirely in code. So the next question is, why do class orders leak so much? Right, so you out-of-memory error, permgen, out-of-memory this permgen, or just heap memory is a very common thing if you just load a typical enterprise application, hit redeploy a few times, and then, it's just a question of how many times. It's not a question of, that whether it happens. It's usually just a question of whether it happens after 5 times or 2 times or 10 times. So, and now we'll try to understand why. The first thing to understand is actually reloading classes in Java is really, really hard. The API, the Java API, the Java language says that basically if once a class has been defined, it's cast in stone. There's no way to undefine it. There's no way to change it. There's no way to load it. With an exception of hot-swap, which allows you to replace method bodies. But generally, it's cast in stone, right? So generally, the only way to really update a class in memory in a Java application is to create a completely new class order, reload all the classes from the new class files so they get updated, and then you somehow have to move the object there. And the typical way, like in Java, is that you just throw away all the old objects, like throw away the old class order and create all the objects from scratch. And this is why redeployment actually takes so damn long, because we're reloading all the configuration, recreating all that state from complete scratch, right? So that's what takes the time. But let's go to the code now. Yeah. This is really annoying. Oh, there you go. That's better. So let's go to the code now. Let's close this. So now we're going to build an application server. I have only 10 minutes, so it's going to be a little bit feature limited. But nevertheless, it's going to be enough purposes. So this is the app server. It has a web app. It supports deploying only one web app, fortunately. We're going to add support for more later. So it has a mainnet method, and all it does, it creates, so it goes in a loop, and actually continuously redeploys that web app, right? So what it does is creates it from the factory, then it does some print line, so web app can send a message, and also it has a counter in it, so we can plus the counter, and plus actually returns the content of the counter. So this is the counter so that the web application will have some state, right? Of course, it's a web application, and then we just sleep for 200 milliseconds. So let's just for a second look at the web app. So it doesn't have anything much. Messages, which version is it, and the plus just increments the counter like. So nothing complex here. So let's start that. Okay. So what is happening now? That remember I told you that there's no way to move the state. So on every cycle, the web app is created from scratch. So the counter is always 0. So we throw away all our state. This is bad. Actually, want our state. But let's check if redeploying actually works. So yeah, so the class is actually reloaded, right? So wait, but why is it reloaded? Okay, so let's look at what the web factory actually does. So first of all, this method is everything that is wrong with Java. I like it with Java 8, it's a little bit better. Okay, and this is actually what we're doing. So we're creating, on every time we deploy, like as I said, the only way to reload anything in Java is to create a new class loader or use Arable. But here we create a new class loader, and basically what it does is, like here, this part is actually reverse delegation again. We want to load classes from the class loader and not from the parent class loader. Here it is safe because I know how to do that, but generally it is not safe. And so we create a new class loader, which is basically, and then we use that class loader to load the class and create a new instance. So that's why the state is being reloaded. So now we go back. Okay, but the problem is that the class is being reloaded, but we don't preserve the state. So how do you preserve the state? You just do a copy, right? So here's the interesting part is that mostly all you have to do, this is basically how a user session is copied on the redeploy, the same way you can copy different state. So I'm just going to create it here as well. And notice that just copies the counter state, right? So this is the only way how you can preserve state in Java. You can just somehow recreate it and copy it. Not terribly interesting. All right. We stop. And we also stop Tomcat because we don't actually need it anymore. Now we restart. Okay. So now we actually have also the counter going. So we have the state. So we have a fairly feature-rich app server. And now we're going to see how class loaders leak. So, and I'm going to add a leak. So I'm going back to the web app. I'm going to add a leak. Let's see what it does. Yes, it absolutely imports everything. Hello? What's going on? Damn it. This is not good. My link is right here. You bastard. Start seeing it. Sometimes I hate Eclipse. No. I don't specifically mind anything. Okay, now it's actually good. Yeah, all is well. Okay. So let's go back. Okay, so let's see what happens. First of all, let's take a look at the class leak. Oh, sorry. I just meant really class leak. So class leak is a super nothing class. It's basically all it does is contain another leak. Right, so it's very tiny little class, doesn't do anything. So now, if we go to web, then web app contains a leak. But again, that leak has no references to web app actually. And web app also contains a cache. This is to give the web app itself some weight. So it's it's a million of longs, which is like 4 megabytes, I think. And so here's the interesting part where we copy the application. We now actually introduce a leak. And what we do is that, so what we do, we add another leak in the chain on the copy. So if you see the method leak, then it just creates a new leak, wraps a new leak around the previous leak, right? And this is just calls that method. So what that means is that every time we redeploy, we add another leak into the chain, and we hold on to the last leak, right? So we never hold on to the previous web app. We don't do anything like that. So let's run it a bit and see what happens. So why am I doing that? I'm actually trying to reproduce a very common thing that happens in the application servers, where just one class somewhere is getting stuck, right? Not anything else, just one class somewhere is referenced either by the next version or by the application server or by something, like, logging framework or whatever, just holds on to one class from your application, right? So leak is supposed to be that class. And turns out that it's very, very dangerous. So let's see, boom. So first of all, one very nice thing I can recommend is the reason why I write now the heap dump is because I put this nice argument into my app, which is -xx plus heap dump on out of memory error. It's actually very much worthwhile to have that everywhere, because when you run out of memory, then you'll get a heap dump, which you can actually do something with. And if you do want to do something with a heap dump, then there's an amazing free tool for that, which is called the Eclipse Memory Analyzer. So if you just refresh this, I should see the, yeah, so I see this. Okay, yes, whatever. And okay, and so the Eclipse Memory Analyzer has this thing, which I think is the dominator tree. Yeah. So, and the dominator tree is actually great. So remember, we put 4 megabytes in our cache, but somehow the class loader is now 120 megabytes. Let's go in it. So we see that the app server actually holds 120 megabytes. Going to web app, and here we see the web itself only has 8 megabytes, but somehow the leak is 112 megabytes. And remember that the leak was just a tiny little class, right? It didn't have any references to web app, didn't have reference to anything, and we introduced one more leak for every redeploy. It turns out that yes, so leak, that every leak has a reference to the class leak. Every class, remember, every class has a reference to its class loader. So the class loader was this temporary class loader, and every class loader has a reference to all of its classes, including the web app. And every class has a reference to all the static fields. So the way it actually looks is like this, that every class loader has a reference to its classes, its static fields, and obviously every object has a reference to class, every class has a reference to class loader, and so altogether it looks like this. Only the top two should be web app.class, web app factory, $1. So we have a chain of leaks, but every leak drags along with it the whole class loader and all the classes loaded in that class loader and all the static fields loaded in those held by those classes. So this is a very live explanation why do application containers run out of memory. Because if you accidentally manage to leak one class in your application, it just dragged along the whole application with it, right? So this is the big problem. It's really easy in Java to leak just one class. It's really hard to trace it. You can use Eclipse Memory Analyzer and you can do it, but honestly, it's just, this is kind of coming to the point that class loaders were made for Java applets, not for Java application containers. So unfortunately, although in development it's fine to do redeploys, in production it's really very tricky to get it to the point where it actually works.
Can you show the example again?
Yes, of course. So the showing example again, you mean this one? Or?
Yeah.
Well, this is the code actually. This is the most relevant code. So we call the method copy every cycle, and we just add another leak in the chain. And leak itself doesn't have absolutely any references to anything, but it has a reference to the class loader, and that's the problem. So, okay, I have little time left, so I'll try to, I'm again skipping the state of the art. But, this is the big problem. So what are the possible solutions? Well, one solution that I used to take about was OSGi, Tables, NetBeans, but truthfully, they have more or less the same problems. Just like modern class loaders, they try to do this one class loader per every jar file, and then they try to kind of remove these dependencies and like root all dependencies from some centralized repository. The problem is that you get exactly the same problems, slightly different flavor, because in reality, some of the things can be verified by tooling, most of the things cannot. Class order leaking basically almost cannot be prevented in Java. It's just too easy to do, and it's actually easier to leak classes when you have a lot of class orders, which all the systems have. So I'm just gonna switch to problems. Easy to leak. But the question is, how do we really fix it? How to ensure that this never happens in production, right? So how to reduce the number of class orders. And honestly, everybody else in the world does not use class orders or something like that for updating code. They use processes, right? So process is a natural abstraction for isolation. The process actually has its own heap, and nobody else can refer to that heap. So memory leaks between processes are impossible. By definition, we have to copy everything between processes. It's widely used outside Java. Unfortunately, in Java, it doesn't go anywhere so far. But what you can do, the very simple thing is just, and what almost everybody probably does here, is you never redeploy in production, you restart the whole server, right, on every update, because that's the only safe way to make sure that you're not out of memory. So in this talk, you already learned how to solve the main class order problems. You learned that you shouldn't ever redeploy in production, which are the two main messages. There are actually other ways also around this, so hopefully someday processes will come natively to Java. Meanwhile, there's workarounds. One workaround that I'm going to pitch you, which is our workaround, is also hot patching, which basically means that it's kind of a way to bypass closures where you update the quoted resources without creating a new instance of anything, so just memory, which we learned how to do. And so we have actually a product called Lifelevel, which does safe hot patching in production, which guarantees no leaks, and which also does automated rolling restarts in case where hot patching cannot be applied. So if you just plug it into production, you actually get very safe and very quick updates. I'm not going to pitch it extensively. Honestly, this talk is not about products, but if you do want to learn more about it, then come to my talk tomorrow. It's called Pragmatic Continuous Delivery. It actually talks also much wider than just about our products. It talks about how to generally set up your production environment so that the patches would flow nicely from development to production. But I think it also talks about good stuff in this context. And also I invite you to visit our booth, which is in the Grand Ballroom, I think, of CoreUp, and learn more about both products, or ask also questions for me if you have any. So, and finally, just to conclude, so remember that if you do have any class order problems, the most important thing is to validate your assumptions. To leak any class orders, it's enough to leak any object. Processes are the only isolation abstraction that actually works well for updates, and hot patching is like a symbiotic alternative. Thank you very much. Questions are welcome.